let's, it says find for sine 2 theta. This is a problem having to do with similar to what we did before, but you're going to boil this down. We're going to come back to this particular problem, but what you want to do is get it down to a function first, and then solve for this sine 2 theta. And that's the thing that I want to do right now. Go to a blank spot, and would you write sine 2 theta equal to 1/2. We're going to start that first. I'm going to do a couple of these and show you how interesting they are. Sine 2 theta equals 1/2. How many values on the unit circle are going to give you sine of 2 theta equal to 1/2? Well, let's look at sine of theta equal to 1/2. Cover up the 2 theta here for those watching at home. Here, we'll cover up this 2 theta. Sine of theta equal 1/2. Where does that happen? Where does sine of theta equal to 1/2 happen? What arc lengths? Pi over 6. See how I did that? Sine is y, and I went kind of halfway up, made a little line. The other one is going to be what? 5 pi over 6. So you agree that this 2 theta now is equal to pi over 6, or it could be equal to 5 pi over 6, correct? Now you can find all the possible values that exist by adding what? 2 pi k. Would you do that for me for both of those? That'll get you all the values. Thing is, you're not looking for 2 theta. What are you looking for? You're looking for theta, all the values of theta. And if you do that, it's going to double the number of answers that you're going to have. So if we want to know what theta is, you're going to divide both sides by 2. And both sides by 2 will get you pi over 12 plus pi k. Or in other words, this one and this one, this one, and this one. Those are the 4 values that you're going to get. And I got to do this one divided by 2 as well. Theta equals 5 pi over 12 plus pi k. And then going on into infinity. But do you see how sine theta equals 1/2 gave me only 2 values, and now we have 4? You okay with that? Okay, let's try another one. Let's go sine 3 theta. Somebody still writing? Sure.
How come we wouldn't use cosine equal this?
You could, but that's what gave us that.
Oh.
But we're just trying to find the values of theta where this is true. And those values will be pi over 12, add pi will be 13 pi over 12. 5 pi over 12, add pi gives you 17 pi over 12. Between 0 and 2 pi, those are the 4. Okay, let's try another one. Let's do cosine theta. Cosine 2 theta is equal to, oh no, am I going to do this? It's too cruel. Square root of 3 over 2, but negative. What's wrong with me? Circle, yep. 2 on the regular circle. So square root of 3 over 2, that's the cosine, that's the x. It's going to be way out here. It's going to be here pretty much and here pretty much. These are the 2 values. So 2 theta is going to be equal to what? What would this one be? There's got 5 pi over 6 again, and this one, 7 pi over 6. Good. Or you could say negative 5 pi over 6, but let's stick with this. All right, and so 2 theta is 5 pi over 6, and the other is 2 theta is equal to 7 pi over 6. And if we want all the possible ones, we go 2 pi k plus 2 pi k. Solving for theta, though, theta, to make this work, is going to be 5 pi over 12 plus pi k. And this one's going to be 7 pi over 12 plus pi k. Are you seeing the patterns here? And so it'll be 5 pi over 12. 5 pi over 12. Is that about here? And then this one, 7 pi over 12, will be about here, I think. So those, now you're going to get 4 of those. Are you doing okay? Let's try one more. You ready? Sine again. 17 theta. No, I'm not going to do 17 theta. That's just cruel. Let's do 3 theta, though. Equal to 1. Sine 3 theta equal to 1. And here's your circle. And that's, should I do that or should I do, yeah, I started this. So sine, when is sine theta? Cover up the 3 theta. When is sine theta equal to 1? There you go. Pi over 2. And is that the only case between 0 and 2 pi? It is. So 3 theta is equal to pi over 2 plus 2 pi k. Now, what's theta going to be equal to? Plus 2 pi over 3k. Yeah. So pi over 6 is about here. And then we're going to go about here, I think. And those are the 3 values that we'll have. You feeling good about this? Yeah. Wouldn't it be nice if it made sense, though? Wouldn't that be nice, Berlin? It would be. Well, that's what we're going to get to next with some graphing. So would you go to, skip that, here we go. We're going to do some graphing, and we're going to talk about something you are familiar with, and that is the sine curve. What's the sine of 0? Sine of 0 is 0. So we start there, it goes up, down, and up again. Show me with your iPads you found this spot. It's kind of brownish slide. Good. Kaylee, did you find it? Great. Okay. All right. So what's the normal period from one cycle? What's the normal period? 2 pi, right? Goes up, down, back. Sines, this is 3 pi over, or pi over 2, 3 pi over 2. This is pi, this is 2 pi. All right? So this point up here is called the amplitude. That's A. A is the amplitude. Okay? B is a number that you use to find the period. You're going to go 2 pi over the period to get B. So I can't draw B, but the period is going to be helpful in finding B. 2 pi over the period. Y equals sine x. What's the period of that? How many? What's the period in radians? 2 pi, right? So what's the number in front of the x? 1. So that makes sense. 1 times 2 pi. What if the period was half as big? Pi. Okay? How many cycles could you get between 0 and 2 pi? If the period was pi, here's pi. If the period was pi, how many could you get between 0 and 2 pi? 2. Let's see if that works. The period is pi. Do I get B equal to 2? Yeah. So B is the number of cycles between 0 and 2 pi. Okay. C is going to be the first peak. The x value of the first peak. And D is just the vertical shift. Okay, let's try one here. This looks like y equals 4 sine 2 x minus pi over 4 plus 1. You need to factor out first. What's a in this example? The number out in front. 4, yep. Okay, what's b going to be? 2. So the period is going to be 2 pi over b. You just do a little algebra here, switch those. So 2 pi over 2 was pi. We got that already. Remember that. C is what in this example? What's C? Careful. Is it negative? It's x minus c. Is it negative or positive pi over 4? Positive. Pi over 4 to the right, just like we always had. And then what's this 1 business? That's the vertical shift. So D is going to be up 1. So let's sketch it. Start with plain old ordinary sine curve. How far do we go up? 4. Okay. And we go down to negative 4. Great. And then 1 period was pi, so this is pi. And put in the middle, if you would, pi over 2. Let's split it again, pi over 4. Anybody know why I split it again? That's the shift. So you can see it. So I'm going to take this green, and I'm going to shift it to the right, pi over 4. And I have one more thing to do, and what's that? Move it up 1, yep. So if I do that, it's going to go between negative 3 and probably 5. And that is how you sketch a translated graph for any period, any amplitude, any phase shift, any vertical shift. Isn't that interesting? Kind of cool. We used to spend a week doing that. You just did it in 5 minutes. Cosine, same thing. Same thing with cosine, except the cosine curve, what's the cosine of 0? 1. So what we're going to start with here is 1, and then it's going to make this shape. 1 period was normally 2 pi. Split it in the middle is pi, and then 1 to negative 1. That's your regular cosine. I'm going to give you a little task. See how you do. Here is my example. I want you to find A, B, C, and D, and then see if you can sketch it. And we'll go over it in just a moment. So what did you call A for this example? Negative 3, that's your A. Yep. What does the negative mean? It's going to flip over the x-axis. We'll just write flip here. What is B from your problem? 1/4. So the period is going to be 2 pi over B, which is 2 pi over a 4th. What is that? Yes, that's going to be 8 pi. Good. C, careful with C. It's x minus something. I see the pi over 2, but it's going to be shifted which way? Left, because if you think about it, x minus a negative pi over 2 kind of works. Real quickly with shifts, if you have y equal to x squared, where's the vertex? Where is the x value of the vertex? 0. If I shifted over here, what's the x value of the vertex? Oh, I suppose I should give you something here, sorry. X minus 2 squared. What's the x value of the vertex? 2. Now, what makes this 0? What makes the y value 0? 0. What makes this y value 0? 2. See why the x minus makes that 0? So if you want to shift it over here at -5, okay, what's going to make this y value 0? What's going to make that y value 0? -5. So what does this have to be? Plus. Make sense? Same thing here. The x value that makes this 0 is -pi/2. So that's why the negative. Well, it's a little different with cosine because it's shifted, but that's the general idea. And then do we have a d for this one? Nope, thank goodness we don't have a d. Hooray. So now you're ready to sketch it. You start by sketching a cosine curve. So we do that. And then what does the -3 do again? Flip it? Now, I don't mean to brag, but I can just flip that with my computer. Sorry, you can't do that. I'm not really sorry. Okay, so how high does this go? 3 and -3. Good. Now, the period from here to here is going to be what? 8 pi. What's the middle? 4 pi. What's the middle of that? What's the middle of that? What's the middle of that? That's how much we're going to shift that to the left. That little tiny bit. So I'm going to draw this and shift it a little bit. I mean, not very much to the left, pi/2. And no up or down. How many got something like that? And it doesn't have to be fussy. What's the best way to draw a graph? Absolute best way. If you're going to be perfectly accurate, what's the best way? Calculator or computer, right? But this is just trying to get an idea of what these values are. Real quickly with tangent, the only thing with tangent you need to know is that it really doesn't have an amplitude, but it does have some asymptotes. So would you sketch those asymptotes for me? And normally, regular tangent goes from -pi/2 to pi/2. Doesn't really have an amplitude, but what we do to fake it is we go halfway in the middle. What's the tangent of pi/4? If you remember, tangent of pi/4 is? That's sort of the amplitude of it. It's not really, but it's sort of the amplitude. So if you took that example, y equal to 2/3 tangent pi x minus 1. Okay, what's a? 2/3. So this number changes to a 2/3 and -2/3. That's sort of how you would sketch it. B is interesting. B is going to be, now for ordinary sine and cosine, it was 2 pi, but for ordinary tangent, how far is it from pi/2 to -pi/2? How far is that? That's only pi. So instead of going 2 pi/k, it's pi/k. That's the difference between tangent and all the rest. Well, in this case, pi b is going to be pi over the period. Okay, so now we have this period here. The period is what we're looking for. It's going to be pi over pi. And what's pi over the period of pi? 1. So therefore, the period's just going to be 1. This is kind of a weird one, but it's kind of neat too. So if this whole period is 1, which we figured out by going pi over b, this is b, then this is 0. How far is this guy out here? Half. So this is going to be a half, and this is going to be a -half. And that's really all I want to say about graphing. When we sketch graphs, when we can do the vertical shift, I think there's a d as -1. We can move everything down again. This goes up to infinity, and we can move it down 1. No problem. We can do that, and you'll see that work out. So why are we doing this? What is the point? Well, let's go back to sine theta equal to 1 over the square root of 2. Okay? Let's go back to this one. Here's my unit circle. What arc length does this happen 1 over the square root of 2? Did anybody know? What's one place where it happens? Pi over 4. And what's the other place? Do we go down or across? Across 3 pi over 4. Now, you've done this before, and solving always seemed crazy and never make any sense. I'm hoping it'll make sense in 1 minute. Watch this. So those are the two answers, right? What did we say happened when we did sine 3 theta equal 1 over square root of 2? What happened to that? Well, we have 3 theta equal to 1 over pi over 4, and we had 3 theta equal to, what is it, 3 pi over 4? Add 2 pi k, add 2 pi k, divide by 3, you get pi over 12, 2 pi over 3k. What was this one? 3 pi over 12, or pi over 4, plus 2 pi k over 3. Okay, you ready for things to make sense? How many answers are these going to give you? How many total answers? There's 3 here, 3 here. That's going to give us 6, right? So look at what happens when you graph the sine of theta, this one up here, and you go like this. How many answers do you get? 2. You get 1 here, which is pi over 4, by the way, and this one here, which is 3 pi over 4. You can visualize that. What happens when we do sine 3 theta? How many squiggles are there between 0 and 3 pi? 3. 1, 2, 3. Now how many answers do you see? 1, 2, 3, 4, 5, 6. See how that graphing connects with the solving? And that's really what I want you to be able to do.